Hello everybody, this is Rochan here. Welcome to Learn with Rochan. So this is the third video of chapter Amines, Class 12 Organic Chemistry. Last two videos we have covered the introduction about amines and the six main reactions of preparations of amines. Today let us look at few physical and chemical properties. Physical properties of amines. So under physical property, see methylamine, dimethylamine and trimethylamine are going to be gases with some ammonical odor itself, odor of ammonia. Now if you take few higher members, so they are going to be liquids with fishy odor. With fishy odor if you take higher amines. Now what about aromatic amines? Aromatic amines are also going to be, they are going to be colorless liquids. Aromatic amines are going to be colorless liquid with fishy odor. So here one point to notice, this is fishy odor again, but if they turn into reddish brown liquid, they can turn into reddish brown liquid. When is this going to be possible? When they are exposed to atmospheric oxidation. When they're exposed to atmospheric oxidation. So when they undergo oxidation, colorless liquids of aromatic amines will change into reddish brown liquid. Okay, this is about basic property, basic physical property of amines. Now, after this, let us look at boiling point. So here we have a slight comparison, like how amines have higher boiling point and melting point than alkanes. So if you take methane and methanamine, of course methanamine is going to have higher boiling point and melting point, because in this if you see no hydrogen bonding is present, which means the bond can be broken easily and boiling point is lesser. But in this you can have hydrogen bonding, two hydrogen bonding is possible. So there is strength of NH bond is more, breaking is less. So that's why boiling point will increase. So this is going to be less volatile because it has more boiling point. This is going to be more volatile. This is all you have to know about with respect to amines and alkanes. Now coming to alcohols and amines. Alcohols will have more boiling point. Okay, because in alcohols the hydrogen bonding is stronger. So if you take methanamine itself and methanol, alcohols will have more boiling point and melting point because the hydrogen bond here is stronger. Okay, so that is all we have to note under the boiling point of amines. Now let us look at solubility. Solubility of amines. What under this? So you have to remember that lower members like carbon 1 to 5 carbon amines, they are going to be soluble in water. Okay, so this you have to note. Okay, polarity of NH bond and hydrogen bonding occurs in water. Okay, but higher members of amines are going to be insoluble in water. So C1 carbon, 1 carbon amine to 5 carbon amines are soluble in water. Okay. Then if you take higher members, they are insoluble. Higher members are going to be insoluble in water. See, when you take higher members, it is going to become more hydrophobic because of bulkier groups. So bulkier groups are always going to be hydrophobic. They don't like water. Phobia, hydrophobia. So you can remember like that. So they're going to be hydrophobic. As a result, they're insoluble in water, but they are soluble in organic solvents. In organic solvents, they like organic solvents. So they can be soluble in organic solvents. You should just remember the order of solubility of primary, secondary and tertiary amines. So primary amines are more soluble than secondary amines are more soluble than tertiary amines. See what happens in primary amines are NH2. Here with N one hydrogen bond can happen. H2 are there. One hydrogen bond here, one hydrogen bond here. Totally 3 hydrogen bonds can be formed. If you take secondary amine, here one. So you can form 2 hydrogen bonds. In tertiary amines, only nitrogen can form hydrogen bond. So 1 hydrogen bond. Okay. So primary amines can be more soluble because they can easily form bonds with water when they're added into water. They can easily form hydrogen bond. You know, water also has hydrogen bond, correct? H2O. Water also has hydrogen bond like this. So when they are added into water, they can easily form hydrogen bonds. Whichever amine can easily form hydrogen bond is going to be more soluble in water. That is all we have to know. Now coming to most important part, that is chemical properties. Chemical properties of amines. First, before we go into depth of reactions, what we have to know is whether amines are basic or acidic. Of course, amines are, what do you think? They are going to be basic in nature. Now just see, I have taken a primary amine here. We all know nitrogen is going to have a lone pair. Now just observe, when I add amine in water, this water, you know, it will break into this, correct? So what will happen? This H plus, the lone pair can take the H plus. So amines are basic. Why? Because there is presence of lone pair on nitrogen, which acts as Bronsted base. What do you mean by Bronsted base? It can accept hydrogen. So hydrogen acceptors are going to be called base. Okay. So here, in because of lone pair, this H plus can be accommodated. So what you will get on the RH right hand side is going to be NH3, one H will come and plus, okay, plus OH minus as it is. Okay, so this is called what? This is called protonated amine. This is called protonated amine. Okay, so that is the reason why we can call amines as basic. So one thing you should know, that Lewis bases are lone pair donators, which means hydrogen acceptors. Okay, this part if you know, any question with respect to Lewis acid, Lewis base and basicity, or if it is acidic or basic, we will be able to answer. And last year concept one we have learned is about Kb and pKb value. So if Kb value for a base is more, then it is stronger base. Okay. But if pKb value of a base is more, then it is weaker base. So on this, most of the competitive exam questions are based sometimes. Order of basic nature they can ask. So whichever is going to have higher Kb value will be more basic. Whichever has higher pKb value, they are going to be less basic. So this one relation we have to remember. Now in this video we will stop here, but in the next video let us go into the fascinating comparison between basic nature of many compounds, and we will look into many reactions. Many reactions are there with respect to amines. So we will see ammonia, we will see amine. So which is more basic between ammonia and amine. Then we can also see which is more basic between primary, secondary, tertiary amines, based on whether they're in gaseous state or whether they're in aqueous state. We will see in aniline and ammonia, which is going to be more basic. Okay, what if you add, or in aromatic amines, which group if you attach to the benzene ring, which group if you attach, will the basic nature increase or will the basic nature decrease? So we will be able to see all this. It is very very interesting and very easy as well. So I hope this video was clear. Any doubts, any suggestions, please do put it in the comment section, and please do like, share and subscribe. So until next video, take care, bye.